Okay, for people who are joining this live stream, we are looking at incremental language development for Wolfram language, and we have an assortment of topics for today. Okay, first up here, we have encrypt, and the question is, should we have a standard? We have encrypt, we have hash, and what are some things that are non-recreational, so to speak, that are to do with sort of elementary ciphers? Comments?
I mean, most of my familiarity with elementary ciphers is either recreational or as kind of an introduction into cryptography. You learn something like ROT 13 to understand the basic idea of offsetting text, but
I mean, things like ROT 13 can be used as encoding in some places, like in production, but it's mostly educational for what I've seen.
We don't have ROT 13 listed here.
Well, ROT 13 is like Caesar cipher with key 13.
Oh, okay.
Yeah. But like Caesar cipher was key 3, but in this implementation, there is in Wolfram function repository, you can put any key.
Okay. You mean Julius himself used 3 as his offset?
Well, that's what historians believe, yeah.
Okay. Okay. Well, so next question. This does not fit into the encrypt framework. Is that true?
I don't think it should.
Explain.
Even if it could. Like one thing is that like it's only, well, as it is now, like Caesar cipher, as it was historically, is defined now for strings of Latin alphabet. Encrypt does what? Expressions, byte arrays. Are we gonna redefine that, or are we gonna just error?
It would be ahistorical to have Caesar cipher work on byte arrays. I agree, but
Yes.
structurally, I mean, what would be this? Okay, so your proposal is, I mean, I don't think this should be. Is it or is it not the case that for every one of these things, we need a cipher type and we need a key? That's what they take.
And some of them may have more than one thing as the key. Could be, I'm not recall which exactly, but like transposition ciphers may have double, like 2 dimensions as the key, not just one integer, Caesar cipher, or one string as visioner.
Yeah, if you look at the,
go ahead.
I was going to say that if you look at the page for KO cipher, the second to last one, it's a 2 key element. This trivial version is just kind of showing the existing ciphers that are on WFR that are at least somewhat popular.
Right.
Well, I mean, we already have things where there's a key that has many fields. I mean, that's how like symmetric keys work.
Right. I mean, I don't think we need
an more or less the same fields, and that for these ciphers, for each cipher, the key means something different, basically.
Sure. I mean, one option is, I mean, I agree that it probably, these things should not be integrated with the, existing cryptography stuff, but there is also the option that it could kind of be like halfway, like you could have to call, generate classical key or something like that, but then you use encrypt. I don't know. Maybe that's a bad idea also.
Well, let's look at that. I mean, let's look at clearly these are all symmetric ciphers. And there's no, classical public key cipher, obviously, presumably, unless, but what other ancillary functions are there that hang off encrypt? That once you can do encryption, you can also do blah, 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 or all of those things like digital signatures, all dependent on the public key aspect.
Well, we're in cryptography as a field, there are digital signature algorithms that can be based off symmetric ciphers, but its most prominent use has been on public key, private key things.
Okay.
And also, I don't think there's a serious application of using, Caesar ciphers to generate signatures. But I think the thing would be more that if we have a mechanism for using these keys, the workflow should at least be similar to how it is with modern cryptography, where you generate a key, like in the current encrypt framework, you generate a key and then you use it and so on and so forth. And it seems like in this, there's a similar thing of like, well, are we going to have it so you generate a key object and then encrypt with it, or are we going to have it where where it's all in one big function? And it just seems like it would be nice if the workflow is basically the same.
I kind of agree. I mean, the only thing that's different is if we say, I mean, isn't what is it called? Character encode? What is it called? The thing that does base 64 encoding, base encode.
Base encode.
Okay, but I mean, this base encode is not. I mean, that's just we're doing an encoding, as opposed to, which is, arguably, okay, so let's look at what this would look like if we did it, if we had a generate, let's say we had a generate cipher key, for example. I mean, do people call modern crypto systems ciphers, or has that gone out of fashion?
I mean, there's certainly terminology like ciphertext.
Indeed, there's ciphertext, but usually spelt with a Y, isn't it?
I don't think so. It's usually with an I.
Oh, no, it's okay. Yeah. Okay, but let's say we had a generate cipher key, and I mean, when we say generate symmetric key, see, it's a little bit difficult to know. I mean, if we have, I mean, it would be nice. Go ahead.
You just give it this cipher name, and it, internally has some logic. It gives you out a specific thing that you can use as a key for the cipher. So for Caesar, it would give you back an integer. For Visionaire, it would give you a random string.
Well, I don't think it would give you just an integer. It would be just like generate symmetric key.
Yeah, it
gives
can have
you
like
a
a
symmetric
cipher
key
object that has like cipher goes to Caesar, like
right.
Key goes to integer.
I kind of like this idea because in terms of teaching people about modern cryptography, right? Having an analog in elementary ciphers seems useful to me.
Like when I was writing the MOOC, I just used the function repository ciphers, and that like worked fine. So
if you have some cipher key wrapper, which would be used for all the ciphers, then it would fit the encrypt framework.
Yeah, sure.
The first argument, yeah.
By the way, there's Stephen on our live stream is saying, fundamental problem with cryptography in our language is there's no easy way to save the keys you generate. No clearly explained way to preserve the byte array for future use. How come? I mean,
you just WXF or MX.
Well, you just serialize. I mean, you can just copy this. You can save this. You can make an input form of this. But it sounds like a documentation failure on our part.
Like to save this byte array so it's usable with other, encryption schemes and software.
Yeah, you
like
should be able
files
to export that into a file. That's
well, you can say you can export it, can't you, to a PEM file?
Not yet.
Not yet. But,
well, okay. Then we've got at least one person saying we need to be able to do this. Okay, so because that's the thing. I mean, that seems a lot higher priority than getting, 2,000 years later, getting the Julius Caesar thing working. But what is the status of getting PEM file export?
It's in progress. We are aware of that. Yeah.
Okay. All right. Okay. But okay. What would happen? What are the arguments to generate symmetric key?
Remember, it just basically has a big method option. I mean, it has like a password and stuff.
But it has a default password, right?
Or
the first argument is the name of the cipher, and then whatever arguments is needed.
In the method option.
Wait, but that's in the method option though. Yeah.
Method option is kind of overkill, but I don't know. maybe not.
Right, but the main point is that with a symmetric key, the primary thing you're doing is to give the password you want to use, and we have a default, method that's going to be used. Whereas with generate cipher key, with these,
Well, you don't have to give it a password in the generate symmetric key. If you just give it a void, like an empty bracket, it will generate a random key.
no, I know that,
And that's what we want to have for a classical cipher.
So you think with Caesar here, it generated a random number between 0 and
Yes.
Well, 0 isn't a
Because
very
I think
exciting cipher.
if we try to derive it from a password, that would be like very overkill. But
Sure,
in my opinion.
sure. But then, so the thing we would do here is we'd say, Caesar 3 or something, and that we would have the cipher type followed by the the specific key for that cipher. Since we don't know, is that a fair?
Yeah, there will be cipher key and then cipher, comma, whatever data.
Yeah, but then this would turn into a cipher key that presumably, what is that color thing representing in the case of a symmetric key?
It's a hash of internal data made into this fancy, colorful things.
Okay, but so it doesn't. So if I were to generate, if I generate, this, and I generate that again.
Yeah, the picture is the same if for the same key. If the picture is the same, then the key is the same.
And that's not a security issue?
No.
No, it's like a hash.
You cannot recreate the key from this picture.
Okay, what we do with a classical, what we do for the picture type thing for the classical cipher, because
I mean, every one of these objects has like, a different color they use. I mean, wouldn't it just have its own?
Yeah, okay, so it would have a picture of Julius or something if it's a Caesar cipher, but it wouldn't contain any. It would just say cipher Caesar, and it would contain. It would contain the key. If I look inside here, this key is the key that would be necessary to decrypt. So this is the. I'm sorry. I'm just. If you got hold of the cipher key, then you can decrypt everything. Obviously, you can both encrypt and decrypt. Yeah,
that's what a symmetric key is. Yes.
Yes, I know, but we would use cipher key rather than symmetric key to represent, even though we could in principle use the symmetric key infrastructure, but we would use its own sort of cipher key.
I mean, maybe even a more idiot-proof name, like historical cipher key or classical cipher key would be, yeah.
Yeah,
Right.
so that nobody tries to use it to actually encrypt something.
Because I can imagine, yeah, exactly. I mean, I can imagine someone being kind of like, just thinking, oh, a cipher is a code, is how I want to encrypt things, right? And not knowing that
And it
cipher
also takes
kind
less space in memory.
Oh no, right? They do the benchmarking. Wow, this is really the fastest way to do this.
What do we have that's like that? Historical, I mean,
I think we like have entities that's more about that. I don't know, some Wolfram alpha data,
yeah, right.
like historical persons, or
Yeah, right.
like Caesar himself, maybe.
Indeed. Okay, but look, so design-wise, it seems like a nice thing to do. It's just such a long name. I mean, it just feels like because if you imagine using this in some elementary course or something, I mean, Daria, in your cryptography course, how, clearly the WFR functions will have worked just fine.
Well, I use those. Yeah.
Why does this say Caesar decipher? Isn't it
Well,
n
There's
cipher?
a separate cipher function.
Yeah.
It's just the same thing, except the n is negated.
It's like
How would we
decrypt.
deal with that? How would we deal with that with this? Because unlike a symmetric key, where you literally do apply it twice, that's not true with the Caesar cipher.
That's not always. Only in some crypto systems can you apply the symmetric key twice.
Yeah.
Like the symmetric, the historical, the cipher key, whatever it's called, object would just contain the n. It would just say, cipher arrow Caesar, offset arrow 12, and then when it encrypts, it rotates right by 12, and when it decrypts, it rotates left.
I see. Okay.
Like we already have encrypt and decrypt, so Caesar cipher and decipher is like the same thing.
Right. Okay. But so that would be confusing if we were to do it directly with classical cipher. That would be a mess because we would have to have separate encrypt and decrypt functions.
I mean, this is what I meant about how it would be nice if the workflow, even if it's using different function names or something, how if the workflow is at least analogous.
Right. Well, I agree. Okay. So, I mean, generate.
Actually, one other advantage of the workflow being analogous is that people don't say, oh, well, it's easier to encrypt using this system where I just have to call one function.
Indeed.
Right? Like if it's literally going through the same mechanism, it's clear that,
It's also nice that we can do file encryption and all kinds of other things like that. Caesar file encryption and so on. I think it's really nice.
If we're going to let it run on byte arrays, and assuming it's not just going to say no when you give it a byte array, which it probably should.
Like, do we want to offset every single byte? Do we want just to rotate the whole byte array by 3 bytes? It's just like
no. Okay, but
really
listen. If you give it a text file, it can do the encryption. If it's given a
single symbol, yeah, maybe.
No, I think it should just do it on text. And if it isn't text, it complains. Okay, so let's just. I think we're coming up with something good here. The only thing is, what about this name?
Yeah, if you drop historical.
Well, I know, but the problem is there isn't really a generate. The whole point about generate symmetric key is that it has a mode in which it is generating the key. It isn't. This is a little bit of a different operation because here, if I say generate symmetric key, it goes from nothing to a whole big key, right? And generate symmetric key of hello, again, goes from a password to derive the key, right? Whereas in this case, there's not a lot of generation going on. It just is the key.
So if you have
in a symmetric key for IIS, it does a random byte array, and here it will just give you a random integer. So it kind of does generate something.
Well, do you think it should do that?
If you have generate cipher key and we add the first argument, which is a name, then we can say generate cipher key and symmetric. It will be the same as generate symmetric key with no arguments. If you say generate cipher key symmetric comma hello, would be the second use. So it would fit nicely.
Well, you're suggesting that we actually allow non-historical stuff inside
the same function. Yeah, why not?
But then people are just going to use that function instead of using generate symmetric key, which is not what we want.
Right. Because also somebody will end up with something with password Caesar and so on.
I mean, I guess the syntax that you have for generate cipher key is fine. So if you just say it's for Caesar, it gives you a random integer in cipher key. If you said Caesar, 3, it gives you the cipher key object with the key being 3. Then for Visioner, you have generate cipher key Visioner, lemon, and then you have lemon as the key, or you just have Visioner and then gives you a random string of. And then the question is, do we want to have a way to specify the key lengths for Visioner? We should have.
That'd be the third argument. Also fine.
Why isn't it just spaces? If you want the key to be longer, or am I confused? And it's a running key, right? Well, you just are using that.
Yeah, but you can use lemon, or you can use London, which is 6, or you can use a long.
But why can't you just see what you're using? I mean, whatever you're using,
you generate a random one.
Oh, I see. Oh, I see.
So I guess what we're talking about, though, I mean, this is different from generate symmetric key, but it's probably, I think it's fine. I mean, because in generate symmetric key, it has all these cases with passwords and derived keys and stuff like that. But here we're basically saying that one, you have to specify what type of cipher it is, because it's not going to, what's it going to do? Default to Caesar. And then two, all of its arguments are just, they're just custom sets of arguments that just get passed to the generating functions for Caesar or for, whatever other cipher you have.
Yeah.
So yeah.
All right. This sounds like a reasonable thing. So there may be some details. Let's just look at the guide page for cryptography.
There is probably going to be a lot of details. Like, for example, if I recall correctly, like the function repository functions for like Caesar cipher, they either ignore the like specific characters, that have like, oh my God, how do you call them?
Umlauts or like,
I think you should.
Yeah.
I don't know. I that's probably an option, but I would suspect we should pass them through unchanged. But here's another issue. Encrypt returns an encrypted object, but don't you want the Caesar cipher to return a string? Maybe not. Maybe we want it to return an encrypted object also.
If you want to decrypt, you have to know what the cipher was, which is inside the encrypted object.
Which is inside the encrypted object. So encrypted object has the cipher and the encrypted data. So we can have this encrypt and ciphered object that has cipher goes to Caesar, data goes to.
But wait, hold on. Encrypted objects don't have the cipher in them. They usually just have something like the initialization vector or something, which there isn't an initialization vector here, right?
They have a cipher too.
Well, they have the name of the cipher that was used. Is that true?
Yeah.
But they don't need, they don't need that, do they? Because it's like, when you decrypt, you're going to have the key, and then the key
and the key has that information.
But this is more standard to have it. If you go in like RFCs, the ways like the encrypted data is passed through like HTTPS, it usually contains the cipher name as well.
Right, but I think it's kind of unnecessary, right? I don't know. I feel like having it return an encrypted object that you then have to kind of extract the string out of, so that you can include the cipher name seems a little unnecessary.
No, but the point is, if we want the same workflow, it's got to return an encrypted object. If we're going to teach people the workflow by using the Caesar cipher, it's got to return an encrypted object. But what we could do in the encrypted object, normally we just show this color thing. Maybe what we could do is put a preview of some of the text here, just as a way to kind of show, and that way, so that we get kind of the best of both worlds. We both have an encrypted object that follows the standard workflow, and we have something that gives you an indication of what that text, what the encrypted text looks like.
You're going to have first few characters, and then
or maybe instead of picture to show the
yes, that's possible. Maybe just wrap it around in successive lines. Now, most of the rest of this is irrelevant, right? There's nothing we can do with any of these encrypt file, decrypt file. They would work.
Well, if it's a text file, then it just gets the string out of there. Yeah.
Yes.
We could make it work.
All right.
Generate cipher key could also generate symmetric asymmetric key pair if you specify AES, RSA, for example.
I would disagree about doing that.
Yeah, I think that just makes it just means that someone could have a piece of code that just, instead of calling generate symmetric key, is calling this. I think any piece of code that does that is dangerous, because now, you're mixing the fake ciphers from the real ciphers, if you know what I mean.
Well, so yeah, well, that was my argument that we should not assume that the encrypt works only with real ciphers, because for educational purposes, you may want to consider weak keys just to show that they can be broken.
And I think for educational purposes, you should keep them separate.
Right, but if you're generating a weak key with, I don't know, blowfish or something, I think you can have small keys with blowfish. Like, or something like that. It's like you can already do that with generate symmetric key. I mean, you have to do a little bit of work to like tell it to generate something that's really small and insecure, but it's you're going to have to see if you had that same capability inside of generate cipher key, it would be just as sort of, you'd have to specify just as much stuff.
Right.
This thing here, unless they're Unicode characters for that, I don't think we're doing this.
They might be. I have no idea.
There are
Actually.
dancing figures like from the shell column.
I don't think this is this is very amusing.
Although no, actually what it says about remove diacritics. So they just remove the umlauts and things.
No, it's a
they
good
don't
idea.
bother with them.
These are nicely written things from Sander. Very nice. All right, I think it's enough said about this.
Another question: are we gonna, if we do that and we document it, are we gonna cite Sander?
Sure. I mean, what we do is we put things in the function repository saying this has now been included in whatever. That's the usual way we do it.
But so sorry, just as one. I mean, what is the name going to be? Generate cipher key or generate historical cipher key?
Generate
or...
cipher key. By the time you typed in Caesar's name there, if you don't know that it's historical,
yes, you're in trouble.
But I don't believe I ever heard this word visionaire. You were pronouncing that, Daria. I don't think I ever heard. I've only seen it written.
It's a French scientist.
I know that. Yeah, I mean, I know the history. I just have only seen it written.
I think it usually has like a diacritic on the second E.
Yes.
So it's visionary.
Fair enough. Hey, when is your cryptography course coming out?
It's like almost done. It's in post-production. We're having a study group starting January 31st.
Cool.
And the MOOC itself is probably going somewhere, well, maybe a week or two later, because they are putting it all together. Yeah.
Excellent.
It's like almost there.
Excellent. Okay. All right. Let's move on to our next topic here.
Okay. Can I drop then?
Yes. Thank you very much. See ya.
See you. Bye.